How does a uniform cross-section separate prisms from other 3D shapes? Imagine slicing through a solid object and seeing the same shape every time you cut. That's what a uniform cross-section is all about. It means that if you cut a shape parallel to its base, the shape you see remains exactly the same along the entire length. This property is what makes prisms stand out from many other three-dimensional shapes. A prism is a solid shape with two identical flat bases that are parallel to each other. The sides connecting these bases are flat faces, usually rectangles or parallelograms. The key thing about a prism is that no matter where you slice it parallel to the bases, the cross-section is always the same shape and size as the base. So, if the base is a triangle, every cross-section parallel to the base is also a triangle of the same size. If the base is a rectangle, then every slice will be a rectangle of identical dimensions. This consistent cross-section is what sets prisms apart from shapes like pyramids or cones. In a pyramid, the cross-sections get smaller as you move toward the tip or apex. For example, if you slice a pyramid parallel to its base, the shape you see gets narrower and smaller the higher you go. The cross-section is not the same as the base, which is very different from a prism. Another way to think about it is that a prism is like stacking many identical slices of the same shape on top of each other. Because each slice is identical, calculating the volume becomes simple. You just multiply the area of the base by the height or length of the prism. This uniformity makes prisms very predictable and easy to work with in geometry. The sides of a prism are flat and usually rectangular, which makes them easy to measure and analyze. This flatness also helps in construction and design, where consistent shapes are needed for stability and appearance. For example, beams in buildings are often shaped like prisms because their uniform cross-section provides strength and uniform load distribution. In contrast, many other three-dimensional shapes do not have this property. For example, a cone has a circular base, but as you move up the cone, the cross-sections become smaller circles. A sphere has a different shape altogether, with cross-sections that are circles of varying sizes depending on where you slice it. In summary, the defining feature that separates prisms from other three-dimensional shapes is the uniform cross-section. Every slice parallel to the base is identical in shape and size, making prisms easy to identify and analyze. This property is useful in many practical applications, from architecture to manufacturing, where consistent shapes are essential. Understanding this helps you see why prisms are unique among the many shapes in the world of geometry.